Well, here's another worded problem, courtesy of one of my online students, and I found this question pretty interesting, right? A container holds 6 liters of water. And they're asking us now, how many containers can be filled from 25 liters of water? Now, really, what's happening here? I'm going to work this question using two methods. First, I'm going to work it out using a diagram, okay? And just to show you the practical connection so that you can have a better appreciation of what's happening. And secondly, I'm going to work it out algebraically, and then you can make your necessary connections to the algebra and the first method. All right, now good, let's get into it. All right, here it states that a container, and the diagram here, the fraction bar that I have on my left represents my liter, and I'm speaking about here, I'm speaking specifically about this is 1 liter. So I'm speaking about 1 liter of water. Okay, the second diagram here represents my container. So this diagram here represents my container. Okay, so that's my container, and this diagram here represents my 1 liter. Now, really, what I want to capture, if you notice carefully, my liter is divided into 6 equal parts, hence the 6 in my denominator. Okay, here 6 equal parts, and since it stated that out of a total of 6 parts, 5 filled a container. If you notice, my container is divided into 5 equal parts. So I have 1, 2, 3, 4, 5. Beautiful. So let's just work this and check and see what's happening. So if 5 out of 6 parts fills a container, then this would be 1 part. So this 1 part here would fill this 1 part here in my container. Okay, this would be a second part in my liter of water, and that would fill there, and that second part would also fill up this part. Okay, and and this part here now rather would fill this portion here. Okay, good. So we're just matching. All right, so that part here will fill this part here. Good, would fill that part, and 5 parts out of my liter of water would fill the entire container. Okay, that's good. So obviously here you would see that out of every liter, 5 parts would fill a container, and I would have a 1 part. I would have a leftover. I would have 1 part. I would have a leftover of 1 part. Cool. Now, what I'm going to do, I'm just going to copy this diagram, and I'm going to basically use my first 5 diagrams just to establish what I'm trying to get across to you. So first, let me just get this. Let me just copy this quickly, just for you to get an appreciation of what is really happening. All right. So let's copy that and let's paste it. So good. So this is my second diagram. That's my second diagram. Let me get another one. This is my third diagram. Let me get another one. This is my fourth diagram. And let me get another one. This is my fifth diagram. This would be my fifth diagram. So I have a total of 5 sets of drawings here. So here now, let's just go through this quickly. This is my first liter, okay, and my first liter filled 1 container, and I had 1 left over. My second liter filled another container, so that's 2 containers now, and I had an extra part out of that liter left over. My third filled another container, so that's 3 containers, and I had an extra part left over in that. My fourth liter filled another container, and I also had an extra part left over in that liter. And my fifth liter filled 5 containers, and I had another extra part. So if you notice, I have 5 liters here, and the 5 liters filled 5 containers. However, in each liter we had an extra part being left over. Now let's count the additional parts that we had left over. I had 1 here, 2, 3, 4, 5, and if you notice, I'm counting the parts in the liter that is shaded in red, that left over, right? So we have a total of 5 parts left over in each liter. Now remember, if you look carefully, it took 5 parts to fill each container. So what this suggests is that what this is suggesting is that if I should add up the total of parts that are left over, I would get a total of 5, which is required to fill a container. So basically, the amount of parts that's left over can fill another container. So I have 1, 2, 3. Let me just extend this a bit. 4 and 5. So let's shade that now. So if I'm shading the red parts, that would take the first part and I would shade it here. So that's one part. This would be my second part. This would be my third part. And this would be my fourth. And my final part is my fifth part. And what I did, I just took all of these individual parts out of each liter that was left over to fill another container. Okay, so this here is my 6. This is my 6th container. Okay, so and right, so what I'm saying is that for every, and it's quite clear, for every 5 liters, and we can make a statement. So you can say, therefore, every 5 liters of water fills 6 containers. Okay, so every 5 liters of water fills 6 containers, and it is pretty evident there. Okay, so if I want to know how many containers can be filled from 25 liters of water, then by intuition it would suggest then that I could find out how many sets of 5 can I get out of. How many sets of 5 there are in 25. So let's check. I can just divide my 25 by 5. So let's find out how many sets of 5 there are in 25. So I can just say basically 25 divided by 5 is equal to 5 into itself goes once, and 5 into 25 goes 5 times. So I have 5 sets of 5. So I can get 5 sets of 5s out of 25. Now, this implies then that since I have 5 sets of 5s out of 25, to get my total containers that 25 liters of water can fill, I would say basically since 5 liters fills 6 containers, and I could just simply say then 5, since I get 5 sets of 5s, I could say 5 times 6, and that would be equal to 30 containers. Okay, so it's really that easy. So 25 liters of water can fill up at least 30 containers exactly. All right. Now, algebraically, this is pretty easy. I could say then basically I could take my fraction 5 over 6, and I could say 5 over 6, and we could just use equivalent fractions to solve it as a matter of fact. So I could simply say, all right, let's just look at it here algebraically. So I could say 5, let me just bring this up a bit. I think we're going to need a little bit more space to work with. Okay, so I could say here that let me change this. So I could say 5 out of 6 liters can fill is equal to 25 over x. Now again, since I can't just write my variable like that, I would have to say let x represent the total, sorry, this is a O, total containers, this is a L, containers. Okay, bit rushy now. All right, good. This video is a bit too long, so I'm trying to get rid of this. So basically I have a fraction here and I have another fraction here, so we could go by finding the LCD, or we could just cross multiply. Okay, so let me change my color. I could say 6 times 25. Okay, when we have a fraction like this in an equation, we could just cross multiply to solve for the value of the variable, which is the letter x. So I could say 6 times 25, so that's what I'm going to do. 6 times 25, and that would be equal to 5 times x. 5 times x, sorry. So I'm saying 6 times 25 is equal to 150. So there I have a 150, and that is equal to 5x. Now I'm saying what is 5 doing to x, and I can see clearly that's being multiplied, so I must do the opposite, which is to divide through by 5. So I'd say 5 will cancel 5, and 5 into itself once, and 5 into 150 goes 30 times. So therefore my value of x, I would have x is equal to 30 containers. And remember now, when you're given a worded problem, after you have finished your calculation, you should present your answers in words. So I could say, therefore 25 liters of water will fill 30 containers. Okay, and it's that easy. All right, feel free to leave a comment or a question if you're still not clear. All right, bye bye.